All right, welcome, grade 10 learners. This video, I'll be taking you through the multiple choice questions for physical sciences paper 1, which is a physics. All right, if you are joining for the first time, if you haven't subscribed, don't forget to subscribe to our channel. All right, let's start. 4 options are provided as possible answers to the following questions. Each question has only one correct answer. Write only the letter A to D next to the number 1.1 to 1.10 in the answer book. Right now, let's look at the first question. The number of waves passing a point every second is defined as of the wave, speed, amplitude, wavelength, and frequency. The number of waves passing a point every second. Right, you can all see the answer for this one is frequency. Okay, so the answer is D. Hope we are together on this one. That is the definition of what? Of frequency. Right, let's go to the next question. 1.2. Let's look at 1.2 together there. What's happening at 1.2? Okay. All right, you can see the question. What does it say? Two pulses. Two pulses are traveling towards each other along a string, as shown in the diagram below. Those are the two pulses that we see. When the centers of the two pulses meet at P, you get the point. The amplitude of the resulted pulse will be, let's see, these pulses, they are in opposite direction. Now, since they're like this, the bigger pulse minus the smaller pulse. So let's check the answers. Where are they? Oh, that is the answer. That is D. So the answer is D. But if the pulses were like this, what were you going to do, class? If this is A and B, you were going to add A and B. So the answer was going to be A plus B. This time around, they're in opposite direction. That's why we say the bigger one minus the smaller one. All right, let's go to the next question. 1.3. Let's see 1.3. What is happening there? Okay, 1.3. Which one of the combinations below is correct? Is in the correct order of electromagnetic waves in decreasing frequency. All right, let's look at this one. The first one, gamma ray, X-ray, ultraviolet, visible, infrared, microwave. Oh, yes. So, and this other one, I just read the first one, and then we find that the first one is the correct answer. Okay, so this is the in decreasing what? In decreasing frequency. Start from gamma, X-ray, ultraviolet, visible light, and then infrared, and then microwave. Okay, now let's go to the next question. 1.4. Two identical spheres, those are charges, X and Y, on the insulated stands, carry charges of 7 coulomb and negative 12 coulomb respectively. Those are the two forces. The spheres are brought into contact with each other and return to their original positions. The charge on each sphere after contact is. All right, let's try to see. Multiple choice, you don't just choose. You start by calculating. Let's add this one. Minus 12 coulomb. And then with this one, let's divide by 2. Then what do you see there? It will be minus 5. I don't know if you get that. What is the answer here? Is going to be minus is minus 12, yes. So this one is going to be minus 7 plus into minus this one. is going to be a -5 microcoulomb over 2. You see? And then, okay, let's read. What did they say? Two identical spheres. Oh, two identical spheres. On this carries the charges of 7 microcoulomb and 12 nanocoulomb respectively. The sphere are brought into what? Into contact. The spheres are brought into contact, and the spheres are brought into contact with each other and return to their original places. See? So, what is it? The charge on each sphere after contact. What is the answer here? And then let's try to see. Is going to be this one. If you press your calculator, all right, minus, I think there was a mistake in this question. They wanted to say it should be -5. It should be -2.5 microcoulomb on this one. I think there was a mistake on this question. Okay. I think someone was trying to write on this question paper. Right, class. The answer should be -2.5. And there is no option. You remember the formula of saying charge 1 plus charge 2 over 2. This is what I did. You apply those and then you press your calculator. So that was a mistake on that question. That's Limpopo 2023 for you. Now, let's look at the next question. The energy transferred per unit electric charge in a circuit is energy transferred. You see, that is the definition of power. Okay, all right, that is the definition of what? Of power. Yes, is the energy transferred per unit electric charge in the circuit. You look for that and then you win. All right, let's go to the next one. Which one of the following combinations include two scalars quantities and one vector quantity? Remember, a scalar doesn't have what? Scalar doesn't have direction. Vector have magnitude and direction. Now let's look at this one. I'm analyzing them. Okay, displacement is a vector. And then this is a vector, scalar, vector. A speed, it's a scalar, vector, scalar. Okay, it's a scalar. All right, so the answer is C. Right, the answer is C for this one. I hope we are good on that one. Okay. Now, in the equation, this is the equation that we're given. The SI unit of change in time is. Okay, let's try to replace the SI units. What is the SI unit of velocity? Meter per second. What about for this one? Meter per second. We replace only the SI unit. Plus. Oh, okay. Now, let's do this. I think let's find a simple way to make it easy for you. Multiple choice, don't just choose. We work it out. That is a change in time. What is the SI unit of acceleration? Meter per second. Meter per second squared. Change in time, it's second. Right? That will be mass. Let's use mathematics. When you multiply power of the same base, you add the exponents. Okay, so the answer for this thing is meter per second. So that is D. Hope we are together on this one. That is D, the answer for this one. Okay, let's go to the next one. The slope of the tangent to position versus time graph represent. Okay, position versus time graph represent what? Okay, this one represent. Remember when you draw that graph, position versus time. Position should be velocity. Yes. Instantaneous velocity. That is the one we're talking about. Let's talk about an instant thing. Ne? Right. I'm not able to pronounce that word. All right, let's go on, guys. That's wonderful. Now, let's look at this. It's a very good question for us. Question 1.9. A car is traveling at a constant velocity along a straight road. Okay. Then slow down uniformly. Which one of the following represent velocity versus time graph below? Okay, which one of the velocity versus time graphs below best represent the motion of the car? Remember, it is moving at a what? At a constant velocity. It's moving as a what? It's moving at a constant velocity. A car is traveling at a constant velocity along a straight road. It then slows down uniformly. Okay. So, since which one of the velocity versus time graph below best represent the motion of the car? So the answer is what? It's C. The answer is C. It was moving at a constant velocity. It was moving at a constant velocity. It then slowed down uniformly. So when it slowed down, that means, what does it mean, class? It means that the velocity is changing slowly but surely. It was moving at a what? At a constant velocity. That's why it was like that. Okay. Now let's go to the next one. Lastly, a car moving at a speed v has kinetic energy E. If the speed of the car increases to 3v, the kinetic energy will be. Right, let's do it. So you're going to say EK is equal to 1 over 2 mv squared. Now, what are we told, class? The speed increases. Let's go to speed 3 what? 3v. Then we square it like this. So it will be 1 over 2m. This one, let's use mathematics. That is 9 what? That is 9v squared. Check out the common factor of 9. You have 1 over 2 mv squared. So the answer will be 9ek. Yes, so the answer is A. Okay? That is how you do it. Don't just choose in the multiple choice, guys. All the best till we meet on the next question. All right.